Hello everybody and welcome to Lesson 11 Group Problems. Question number 1, Part A says indicate the group of enzymes that covalently link amino acids to tRNA molecules. And the answer to that is amino acyl tRNA synthetases. B, indicate 4 proteins that consume GTP during translation. During the initiation phase, there's IF3 and IF2. And then during elongation, there's EF-TU and EF-G. Indicate 1 molecule that functions as a ribozyme during translation. That's the peptidyl transferase. That's actually the 23S rRNA. Indicate 2 proteins that recognize stop codons. That's release factors 1 and 2. Indicate 1 molecule that forms hydrogen bonds with the Shine-Dalgano sequence. That's the 16S rRNA and the 30S subunit.
Number 2, we have fill in the blanks. The first amino acid in the prokaryote proteins is formylmethionine. An E. coli protein called EF2 delivers charged tRNAs. The initiator tRNA binds to the P site, and then whereas the remaining charged tRNAs bind to the A site. EFG is translation factor that helps the ribosome move 1 codon in the 3' direction along the mRNA. While IF3 is a translation factor that guides the mRNA to the 30S ribosome subunit. The 5' AUG 3' codon is the start codon, while the 5' AUG 3' is an example of the stop codon. Degenerate is a term that indicates more than 1 codon can specify the same amino acid, and the final amino acid is located at the C terminus of the polypeptide.
For number 3, we're given a series of mRNA codons and need to figure out what possible tRNA anticodon sequences could form a hydrogen bond with these. The Wobble rule tells us that there's multiple for each mRNA sequence that we get. The first one we have is UUG from 5' to 3' direction. So our tRNA is going to be anti-parallel, so it'll be 3' to 5', and we'll get the opposite, following the GC-AU rule, we'll get A, and then our third nucleotide, this is the Wobble one. So for number A, the tRNA nucleotides that can match up with this third G are C, and then we have AAA, and AAU, just like this. So you can see that we just do follow the AU and CG rule for the first 2 nucleotides. And the third one, we just look at the table from the PowerPoint to figure out which options we have for the nucleotide that can match up for that third Wobble. So reading the rest of these 3' to 5', for B, we have UCI, UCA, UCG, and UCU. For C, it's AUG, AUI, and AUA. For D, it's UAA, UAU, UAI, and UAG. And for E, it's CGU and CGI.
All right, number 3 asks us about, number 4 asks about a protein called protein X, which is 218 kilodaltons in molecular weight. If the average amino acid is 125 daltons, how many amino acids are found in protein X? Simple conversion factor here for part A, 218,000 daltons, and there are 125 daltons in 1 amino acid, double A. That's going to give us a total of 1744 amino acids in this protein. Question B says, what's the length of the mRNA coding region, the portion of the mRNA that encodes amino acids responsible for producing this protein? All right, and we know that there are 1744 amino acids, and that there are 3 nucleotides. Nucleotide like that per 1 amino acid. Units cancel in all these cases, and we are left with 52, 32 nucleotides. And that is the length of the mRNA in this case. Question C asks us how many GTP molecules are consumed to synthesize each copy of protein X. And every amino acid that is added requires 2 GTP, one for the hydrolysis to attach it to the polypeptide, and another GTP to move it from the A site to the P site. So we'll take our 1744 amino acids, multiply that by 2. It's going to give us 3488 GTP. But we also have to remember that there's 1 GTP required to dissociate the ribosome from the mRNA. So we'll just add 1 right there. Give us 3489 GTP. Part D asks us how many ATP molecules are consumed to synthesize each copy of protein X. ATP are only used to charge your tRNAs. So there's going to be 1 ATP for every tRNA, and there's going to be 1 tRNA for every amino acid. So therefore, we're just going to have 1744 ATP consumed. Question E asks, what is the name of the group of enzymes that consume ATP to assist in the synthesis of protein X? And again, that's going to be our aminoacyl tRNA synthetase.
For question 5, you have to go through the list and figure out which proteins and nucleic acid sequences are involved in translation for each questions. For A, which of the above is involved in translation initiation? We have IF3 tRNA FMET, IF2 16S rRNA, lysocell tRNA synthetase, Shine-Dalgarno, and 5' AUG 3'. For B, which of the above is involved in translation elongation? We have the EF2 16S rRNA, 23S rRNA, and EFG. For C, which of the above is involved in translation termination? We have 5' UGA 3', and RF1. And for D, which of the above is a component of the 7OS chromosome? We have 23S rRNA and 16S RNA. And finally, for E, we have which of the above is found within the mRNA, and we got 5' AUG 3', 5' UGA 3', and the Shine-Dalgarno sequence expression.